Hello friends, this video on DNF block part 23 is brought to you by examfear.com. No more fear from exam. Talk about a very important concept of transition metal, that is colored iron. Before that, let's understand some of the basic concept. See, the colored spectrum range is 400 to 750 nanometer. So if a light has this range 400 to 750 nanometer, 400 to 750 nanometer, so then you can actually see that if the wavelength is in this range 400 to 750, then only you will be able to see that particular object, else you will not be able to. You will see so many rays in front nearby. For example, the rays for the radios, mobile phones, they are in a different range and thus you can't see them. You will see the rays only when it is in the range of 400 to 750 nanometer. Okay, so with this we also know the line spectra concept, that if there is atom and this you put some light, right, the electron goes to a higher excited state and come back. When it comes back, it emits light, or when it goes to a higher excited state also, this electrons emits light because it emits the rays of this range 400 to 750 nanometer sometimes, and thus you see the line spectra. Right, so line spectra is nothing but spectrum of radiation emitted by a substance that has absorbed energy. It's called emission spectrum. We have learned a lot about this. If you want to know more about this, you can watch my video on atoms where we explain this in more better way. Right, same thing, just now what I've told. For example, hydrogen view. This is the electron. It takes up energy. It jumps to a higher orbital. Again, it gives back energy and jumps back to the lower orbital. So this happens in hydrogen. In fact, it happens in all the atoms. And thus this light, if the lambda for this is in the visible range 400 to 750 nanometer, you will actually see color. Right? Same thing is happening in transition metals. Actually. In transition metals, what happens is the d orbital. If you see the d orbitals, just now we have seen, has again 5 subshells and they are different energy level. These 3 are the lower energy, these 3 are the lower energy, and this 2 is higher energy. Right? If you see the math, this is 2 by 5 and this is 3 by 5, I think. Yeah, or other way around. This is 3 by 5 and this is 2 by 5. Yeah. This has the higher energy, this is lower energy. Now if my d orbital electrons are unpaired, for example, I have only 2 electrons here. These 2 electrons keep jumping from these to this. Now since they jump and there is a difference in the energy, when they come back or when they jump, they either absorb light, or when they come back, they emit light. So this light or this ray is in the visible spectrum 400 to 750 nanometer. So this is in this 400 to 750 nanometer. Right? They take some energy. They take energy in this range actually sometimes, and they go to a higher state. Since they take some energy from the sunlight or any light, that particular energy is absorbed and the remaining is transmitted back to the human, and we can see with our eye that color. Okay, and that is the reason. See, any substance which, for example, leaves appear green. Why? Because leaves, they absorb all the light of sunlight except green. So they absorb all the light and they just reflect back green, and we can see that it's green color. Same thing here. They absorb from the sunlight. If you absorb some component, the reflected light will change. The color will change, and that's why we'll see that these d block elements have different colors. But understand that this why I'm talking about this slide. This is the critical slide. D orbital actually is divided into 2 parts. dx, dy, dz has the lower energy level, and dx square minus y square and dz square is higher energy. So electron keep jumping if they are unpaired electron. Only if they are unpaired electron, they have colors. Right? This is the example. This is how a d orbital look. So these 3 actually has lower energy. These 3 has lower energy, and these 2 has higher energy. So electron jumps from these to these, or these to these, and with that it imparts color, and this happens only when there is an unpaired electron. We'll talk about that. Just understand that d orbitals has different energy. Okay, So if you see the D block elements, they have colors, the ions have colors. And why? They are colored, in fact they are colored both in solids and aqueous solution. You see gold is colored. These are all ions of transition metals, and they are colored. And they are colored because of unpaired electron. I just showed you unpaired electron. If there's unpaired electron in this D, they'll move from lower to high orbitals in the D. Okay, so there is a DD transition from this D to this D. Since there is a difference in energy, there is a DD transition, and this transition happens only if there is an unpaired electron. So unpaired electron is the key for the color. In fact, if you see, unpaired electron is key for a lot of things. Unpaired electron is the key for magnetic character. Unpaired electron is the key for color also. Okay, so it is a D orbital unpaired electron and the DD transition. Because of that, you see colors in this ions. Okay, so a compound of transition metal appears colored when there is a frequency of definite energy that is absorbed. I showed you this formula, delta E is equal to h mu. So if the energy that is absorbed has the wavelength of 400 to 750 nanometer, that means the sunlight is absorbed, the reflected light will not have that component of the sunlight, and it will give that color. And this energy is actually required for DD transition. This delta energy, delta E, required for movement from lower d orbital to high d orbital. If that takes the energy, and that energy in the light visible range, that is 400 to 750 nanometer, you see color. Okay, so if you see titanium plus 4, that is colorless. Titanium plus 3 is purple in color. Same thing, vanadium plus 4 is blue, vanadium plus 3 is green, vanadium plus 2 is violet. So different, chromium plus 3 is violet, chromium plus 2 is blue. Okay, manganese plus 3 is violet, manganese plus 2 is pink. Iron plus 3 is yellow, iron plus 2 is green. They are different colors. So actually this color is nothing but the color which is not absorbed. Okay, this is the complementary color. For example, if the color absorbed is violet, the color absorbed is violet, the color observed will be yellow. So in this case, my violet was the color absorbed. Okay, for orange, the color absorbed is blue. For green, anything green, yeah, the color absorbed is red. Okay, for yellow, the color absorbed is violet. And for violet, the color absorbed is red. Because yellow and violet, they are in complementary. Green and red, they are complementary, right? So if there is a red, the color absorbed is green. If the whole iron looks green, the color absorbed is red. Okay, so the complementary color actually you see. Okay, so let me reiterate once again. When the electron from the lower d energy, so we have this lower d energy, moves to or excited to a higher energy, then the energy of excitation is nothing but it corresponds to the frequency of light absorbed. Okay, the frequency of this light generally lies in the visible range, that is 400 to 750 nanometer. 400 to 750 nanometer. Okay, thus it absorbs color, and the corresponding complementary color is visible. For example, the violet is absorbed, you see yellow. The red is absorbed, you see green. Okay, now frequency of the length of the light absorbed depends on the legends also. The legends attached, it depends on that also. Okay, for example, in the aqueous solution, my water molecules are legend. Okay, what are legend? Let me repeat. I think if you don't know, then I can say that legends are nothing but molecules or ions that bind to the central metals to form the coordination complex. Okay, so for example, if I have PT, and in this I have chlorines attached, these will be the legends. We'll talk about these when we talk about the complex ions. So it depends on the charge and also depends on the legends. Thank you.
Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.